Welcome, focused learners and infrastructure admins. Let's jump right into today's explainer. We're tackling Module 6.6 for your Nutanix NCP-MCI 7.5 exam preparation. Specifically, we're going to look at exactly how baseline AOS 7.5 and AHV 11.0 environments handle GPU and vGPU configurations. We'll explore how these highly demanded resources are managed, what happens when things get a little sideways, and exactly what you need to memorize to crush this section of your certification.
Here's our roadmap for today. We're covering 1. Why GPU matters. 2. Pass-through versus vGPU. 3. ADS and VM placement. 4. The exam traps and edge cases. And 5. The key facts you absolutely must memorize.
All right, Part 1. Why GPU matters and the role of ADS.
So before we even compare GPU types, we have to talk about Acropolis Dynamic Scheduling, or ADS. Think of ADS as the brain behind the curtain. It's constantly, proactively monitoring your cluster for compute, storage, and vGPU contention. When it sees a hotspot forming, it builds a migration plan to cool things down. But here's the critical takeaway for your exam. ADS doesn't just react to problems, it's fully in charge of the initial placement of your guest VMs. If a host doesn't have enough room right off the bat, ADS will actually try to defragment the cluster. It'll shuffle existing VMs around just to carve out space for your new workload. It's all about making sure that from the very first boot, workloads get the best possible resource access.
Moving on to Section 2, Pass-through versus vGPU, looking at allocation and capabilities.
Now, what's really fascinating here is how fundamentally different these two models are at the raw hardware level. On one side, you've got GPU pass-through. This is a super rigid one-to-one relationship. One VM gets direct, totally exclusive access to a physical GPU card. No sharing allowed. And definitely write this down for the test, AHV supports a maximum of 4 pass-through GPUs assigned to a single VM. Now contrast that with NVIDIA GRID vGPU on the other side. This takes a single physical GPU and slices it up into discrete virtual GPUs. So multiple guest VMs can share that one physical card at the exact same time, using time-sliced processing cores. It's a classic trade-off, right? Locking down hardware for pure exclusive power versus slicing it up for shared efficiency.
Let's put this into a real-world scenario. Say you power on a new VM. AZOS immediately steps up. First, it scans all your AHV hosts to check for available CPU, memory, and vGPU. It's looking for the perfect fit. Second, if it can't just drop the VM onto a node directly, it triggers that cluster defragmentation we talked about. It literally plays Tetris with your live VMs to open up a slot. Third, and pay close attention because this is a classic exam scenario, if the cluster is running too hot and there's just no way to free up space, the initial placement of that VM fails. It simply will not power on.
Let's look at another example. Day-to-day host node maintenance. You go into Prism Element or Prism Central and place a node into maintenance mode. Your live migratable and high availability VMs, they gracefully float over to other hosts. No problem. But your non-migratable VMs, they get powered off, hard stop. They basically sit there waiting until that node exits maintenance mode before they can automatically power back up. The core reason why is that if a VM is hard-locked to specific hardware on that physical box, it absolutely cannot survive a host evacuation.
So, that begs the question, what exactly makes a VM non-migratory? The exam writer is going to test you on this for sure. A VM is strictly non-migratory if it falls into one of 3 buckets. First up, any VM configured with GPU, PCI, or CPU pass-through. Second, pinned VMs, meaning you set strict host affinity policies binding them to a specific node. And third, VMs running on replication factor 1 or RF1 enabled storage. If you've got any of those configured, live migration is completely off the table.
Okay, Section 3, ADS and VM placement, focusing on managing vGPU migrations.
So, unlike rigid pass-through setups, ADS actually can and will live migrate vGPU-enabled VMs to clear out hotspots or defrag the cluster. But of course, there are strict rules. The destination host absolutely must have a compatible GPU card, and it has to have identical vGPU resources available. Plus, the vGPU-enabled VM itself cannot have any host affinity rules set. If even one of those conditions isn't met, the migration is a no-go.
And we need to talk about high availability for these vGPU VMs. Be super careful here. Nutanix only conditionally supports HEA for NVIDIA GRID vGPU VMs. The documentation uses a very specific phrase. It operates on a commercially reasonable effort.
What does that actually mean? It means the cluster does not actively reserve specific memory or vGPU resources just to guarantee HA. So, if a node fails, HA is going to try its best to restart that vGPU VM on a failover host. But if the exact matching vGPU profile or the right amount of memory isn't available in that exact split second, the VM just won't power on.
Section 4. Exam traps and edge cases. Watch out for these limitations.
All right, let's test your instincts with a classic edge case. Ask yourself, what do you think happens to a GPU pass-through VM when the underlying hypervisor on its host needs an upgrade? Think back to those strict rules of hardware pass-through we just talked about.
Did you guess it? It powers off. Live migration is fundamentally impossible for pass-through VMs. The hypervisor reality is that you just cannot transparently move a direct physical PCIe hardware mapping across a network to a completely different machine. So whether it's a BIOS, baseboard management controller, or hypervisor upgrade, those VMs have to power down and they'll only turn back on automatically when that specific node is fully back online.
Now, you might want to screenshot this slide because these multiple vGPU rules are total exam traps. First off, if you assign multiple vGPUs to a single VM, every single one of them must be the exact same profile type. Absolutely no mixing and matching. Second, you can only use multiple vGPUs if you select the highest vGPU profile type available for that specific physical card. Third, the cluster enforces a dynamic max instances per VM limit based on available resources. Try to exceed it and the VM won't boot. And finally, here's a massive administrative gotcha. The moment you add a vGPU driver to a VM, you break the default Prism Web Console access. You have to make sure you've set up RDP or VNC beforehand if you actually want to manage it.
And check this out. It's a brilliant example of a super specific vendor limitation you need in your back pocket. The docs explicitly warn that NVIDIA does not support Windows guest VMs on the C-Series NVIDIA vGPU types. Keep that little nugget stored away for any tricky troubleshooting questions they throw at you.
Finally, Section 5. Key facts to memorize for our final review.
Okay, let's lock this in. If you memorize these 4 facts, you are golden. Number 1. Pass-through is a strict 1 VM to 1 GPU relationship, while vGPU slices up the pie for shared access. Number 2. ADS isn't passive. It actively defragments your clusters by moving VMs around just to fit new vGPU deployments. Number 3. If a VM is pinned, running RF1 storage, or using pass-through, it is completely non-migratory and will power off during maintenance. And number 4. You absolutely cannot mix vGPU profile types on a single VM. They must match exactly, and for multiples, it has to be the highest profile type available. If you've got these operational rules down, you're going to totally crush the VM placement questions on your exam. But zooming out past the test for a second, with AI and graphics-heavy workloads absolutely exploding right now, how are you going to balance that raw, exclusive power of hardware pass-through against the shared efficiency of vGPUs in your own data centers? It's a massive design challenge. Thanks for hanging out and learning with us on this explainer, and good luck out there on your certification.